what is genome browsing? It's basically displaying data along the sequence of a genome in a graphic way like this. So you have many genome browsers existing. You have desktop applications like IGB. You have Jbrowse2 here. You have Trackster. It's still in the code, I think. You have a UCSC browser, Jbrowse, and PyGenome tracks, special dedicated to UC. And if you look closely to the Galaxy logo, you even have a genome browser within the logo, which means it's quite important in bioinformatics to be able to browse genomic data. So, why Jbrowse2? So, Jbrowse2 is the successor of the first one was Jbrowse from early third millennium. I wasn't born. Then we had Jbrowse around 2010, and then we had Jbrowse2, which is a new version of the genome browser, which was completely rewritten using a modern JavaScript framework. It's based on React, and it's much more modern style. And so now it comes in two flavors. You have a desktop application and a web application. So we are mostly interested in web application, which means you don't have to ask users to install anything on their laptop. It's just go to this URL and you have this beautiful genome browser. One cool thing about Jbrowse2 is that it's just a static HTML code and the images and JavaScript, so you don't need to have a dedicated, complicated web server to set up. You just put it on an Nginx server and it works like this. And it works with many bioinformatics formats, and it's quite good in terms of performance because it indexes data in optimized format, so you can browse all along the genomes quite conveniently. Okay. So why Galaxy tool for Jbrowse2 now? Well, if you're willing to create a Jbrowse instance with data, with a Galaxy, you have to first index your data and convert it to the proper data. So, for example, for the genomes, you need to index it with the SAM2 FAIDX command. And then you have the choice to load this index using the command line interface of Jbrowse or using the web interface of Jbrowse or the desktop application. So it works, but some people don't know how to do it. And by putting Jbrowse2 inside the Galaxy tools, you can cook your own genome browser directly from Galaxy with your own data, which is the result of Galaxy workflows, for example. And you can choose the default styling and configuration of your browser directly from the Galaxy tools, and then you run it and you let the tool do all the preparation of data, indexing, placing it in a good place, tweaking the configuration to show it exactly like you want. And at the end, you just get this data set in your history that is just the static output of the Jbrowse, which is the HTML code, the data, and the configuration files. So you have a static data set that is completely standalone, reproducible, stable. You can share it with your friends all the world, and you can always rerun it if you want to change a little bit the parameters or add new data. So it's quite convenient to add it. And in fact, it's the result of a long story, what I'm presenting today, because, well, Jbrowse is a complicated tool. It's a lot of repeats, conditional sections, options. If you look at it, it can be a bit terrifying at the beginning, especially if you have a lot of data you want to put inside. So historically, we had the first version from Elena, which dates back from 10 years ago. I wasn't born either. And then we had, I started a pull request 4 years ago to try to work on Jbrowse2. At the time, there was some features missing into the new Jbrowse2 rewrite. So it took some time, and I got busy. Then I took a bit of time to work again on it. And then last year, there was the first draft version of the tool that got published on the toolshed for VGB. And it was not yet at the top level of the requirements to be included in IUC, and now these past weeks I worked on the final version of the Jbrowse2, which just got merged this morning by your. Thanks, Bill. I don't know where you are. And so I'm at and I play with the ponies. So how does it work? It looks like that. So just a few screenshots. What has changed in Jbrowse2 compared to the previous one is that you can add multiple genomes inside it. So here you have a big repeat on the tool where you can add as many genomes as you will just by hitting the FASTA file. And then on the right, you can see the different genomes that are displayed, each one in its own box with the corresponding tracks. And all of that is the data set that is on the right. Then when you have your genome sequence, you can add some tracks. So in Jbrowse, they are grouped in categories. So in the tool form, you can add as many categories as you want. They are called track group. And in each group, you can add as many tracks as you want. So each track, you can select the type of the tracks on the right. So you have a GFF, BAM, CRAM, BigWig, any standard thing you can align along the genome. And once you've done that, you select the file corresponding to that in your history, or you can also add multiple files at once. And then you end up with your Jbrowse with all these tracks and a menu on the right where you can select which one you want to display. And it looks like that. So you have the different kind of data types on the top right. And you can see a BAM track, a coverage track, variants, genes, or IC data there. So you have various display of that. And you can tweak also the style of each type of track. So depending on the track type, you have multiple ways to show the data. So for example, for BAM track, you can choose to display the pile-up, so which reads a line on the genome, or a coverage graph. You can play with the color. You can have other options that are specific to each type of data, and you can also select which region of the genome you want to display when you first open the Jbrowse interface. Then we have a few other interesting things like metadata, for example. So in Galaxy, when you generate the tracks that you want to display, you have some metadata in Galaxy. Concerning how they were prepared, this track, which tools was used to generate it, in which version, and so in the tool you can choose to push this metadata to the Jbrowse interface, where you have a faceted tracks selector. So when you have just a few tracks like on the right, it's not very interesting, but when you have a long list of tracks for human data, for example, you can choose to only display certain type of tracks depending on the data type, how they were produced, and other metadata. And from the tool, you can also add your own metadata from tabular file, the key values. So it can be quite useful. Another thing that can be customized with the tool is the feature details panel that can be displayed on Jbrowse. So when you have a list of genes like this, you click on one, and on the right you have a panel like this with information about the genes extracted from GFF. But you can, with a bit of JXL, so it's a JavaScript expression language. So it's kind of simplified JavaScript. You can customize what you want to display on the right, so you can delete something that are not interesting, add new ones, or even add links to external resources. So you can really, from the tool, customize all of this. And I think it's the last main feature. You can index data that was already possible in Jbrowse1. Here it's done a bit differently, but you can, depending on the track type, you can choose to index it or not, which means in the Jbrowse interface, you can search for gene using their name directly, and it will be found by Jbrowse, and will bring you to the position of the gene. Then that's a thing that has changed for Jbrowse2. That's the data sources. So in Jbrowse1, you could only select data from your history, which was nice. With this new tool, you can also use data from external sources using URLs. So for example, if you have data like BAM track or crank track on the S3 server, you can just give the URL what you do and Jbrowse will display it to the user. The only thing is that if you do that, your data set is no longer standalone, which means if the remote server goes down or if you're not connected to internet, your Jbrowse instance will be broken. So it's not ideal for long-term preservation of your Jbrowse instance. New things now in Jbrowse2. It's not only a linear genome browser anymore. So you can have tracks like the synthetic data. So here we have 3 genomes that are grape, peach, and cacao that were aligned using Galaxy. And with this viewer, you can browse synthetic data between this genome. So you see which genes were conserved or rearranged during evolution, and you can move on each genome independently. And as I say, it's not only linear, which means we have other very unusual way to use a genome browser like Galaxy in Jbrowse2, which means you can display plot data for synthetic data, for example. You can have circular representation, and you can have also structural variant representation. So here we have what is called a breakpoint view, where we have 2 different scaffolds of the same genome that are misassembled. And now with Jbrowse, you can see, okay, the first part is on this scaffold, then you have a link to another scaffold where you can see the continuation of the elements. So it's quite useful. It's not yet in the Galaxy 2, but it should be quite straightforward to add in the coming times. And Jbrowse2 has a public plugin store where there are a selection of plugins to display other kinds of data. So I only added the math plugin for now, but we could add much more to add other visualization, also other data sources. So you can have a UCSC plugin, for example, to connect to UCSC sources to get annotation charts from that. And now, performances. Sorry, it was interesting to see if the tool was better than the previous one in terms of performances. So I tried to just load inside it the data from Albula goldensis, that is this fish, fished by Yvan. Nearly 1 gigabytes basis genome with a 300 megabases GLF. So it's the genome from the Atlassian project, so the French EBV project. And if you look at the statistics, so yeah, it was nearly 15 minutes to run on Jbrowse1 and only 2 minutes on Jbrowse2 on my laptop yesterday. And the carbon emission was estimated to be 10 times lower. The resulting data set is 4 times lower. And also, what is very convenient is that there are much less files within the data set. And that's because the Jbrowse1, in fact, was indexing the gene names from GFF, etc., using a lot of tiny JSON files in the tree of the dataset. And now this is gone. We are using a tricks index, which is just 1 or 2 files on the disk, which makes everything about copying, zipping, transferring data between compute nodes and pulsar nodes or whatever much easier and much faster, because yeah, computing file system often don't like to have many bigger files. So now what can we do with all of this? We can use it because if you look at the DTN, there are a few tutorials using Jbrowse, and it's still using Jbrowse1, so we need help probably if you're interested to update all these tutorials to use the new version. And it's also going to be used in EBV projects, so by genome projects, so large-scale sequencing project like VGP, which is already using it, and we are going to use it in Atlassian in the coming weeks for well, the first 100 genomes on each project, and then 4,500 genomes. And the last perspective is Apollo. So Apollo is kind of Google Doc Foundation. Hello, hello, hello. Google Doc Foundation. So it's basically based on Jbrowse with a plugin to make it writable, so people can change the structure of genes or add a functional annotation to genes like names or whatever. So Apollo, there was an old version that is named Apollo 2 that is deployed on usegalaxy.eu. The problem is that it's no longer maintained, and we have some performance issue because we have a lot of user loaded data into it. We have a new version of Apollo, which itself is also a complete rewrite that is based now on Jbrowse2 and looks like on the screenshots there. So we have a plan to, at some point, migrate all that was done on Apollo 2 to Apollo 3. And the current status is that Apollo 3 is still in beta version, and some important features are still missing, like generic authentication mechanisms, some permission management. So we are discussing with the author to implement all of this and hopefully soon propose it in usegalaxy.eu or FR other services. So that's it for Jbrowse2. I'd like to thank all the communities involved, Galaxy, Jbrowse, Jmod, EVP communities, and especially Helena, who made a lot of work on the first version and then helped for the second version of Jbrowse. Bjorn and Ross, who contributed code and reviewed everything to make it usable. And also Colin, who is part of the Jbrowse development team, who helped a lot in adapting it for Galaxy. Thank you for listening. Thanks. Any questions?
Thanks, that was really interesting. Is this already part of any one of the genome assembly workflows used by BGP or Jaeger?
Yeah, the draft version that was merged last year is already used on some workflows with BGP. But I think we should migrate to the new IUC standard version pretty soon.